So far I have discussed the solutions for questions 1 to 23 in the assignment in center of mass and conservation of linear momentum. Next, I am going to discuss the solutions for the questions numbering from 24 to 30 in this class. In case you don't have any doubts in the questions numbering from 24 to 30, you can skip this class and go to the next class. So I am going to show you the question number 24 on the screen again. You look at the question number 24 on the screen. Two particles A and B of masses m and 2m are moving towards each other due to mutual gravitational force. When they are at capital A, within bracket small a comma 2 small a, and B, capital B within bracket minus 2a comma minus 2a, on the xy plane they meet at a distance small d from A, then D is. This problem comes under one of the special cases I have discussed earlier. As I discussed in one of the special cases earlier, that if 2 point masses m1 and m2 are initially at rest, and if they start moving towards each other only due to the mutual internal forces of attraction, and if such that no external forces act on system, then the two particles will meet or collide at the position of their center of mass. Therefore, you have to find the position of the center of mass of the two particles. That means you have to find the position of center of mass system of the two particles, or distance of the position of center of mass system of the two particles from first particle. So x coordinate of the center of mass of the system of the two particles is equal to m1 x1 plus m2 x2 by m1 plus m2. Here m1 equal to m, x1 equal to a, m2 is 2m, x2 is minus 2a. You can try to simplify this. So you get x squared as center of mass as minus a. So y coordinate of center of mass will be equal to m1 y1 plus m2 y2 by m1 plus m2. Here m1 equal to m, y1 is 2a, m2 is 2m, y2 is minus 2a. So this will be 2ma minus 4ma by 3m. So y coordinate center of mass of the two particles, you get minus 2a by 3. So center of mass system of the two masses lies in between the two masses. On the line, if A is the position, initial position of first particle, B is initial position of second particle. Let C be the position center of mass system of the two particles. D is the distance of center of mass system of the two particles from the initial position of the first particle. That means D1 equal to D. So distance D or D1 between A and C, using the formula for distance between 2 point masses, is equal to under root of x squared at center of mass minus x1 whole square, using the formula for distance between 2 points. Come on, simplify this yourself and complete the calculation. So I get the answer as 5A. In case you need more time to copy the solution of the problem, you can take a pause and take your own time to complete the solution of the problem. So for question number 24, third option is the answer. See the question number 25. 3 masses 2 kg, 3 kg and 5 kg are moving with velocities 3 meter per second east, 4 meter per second west and 5 meter per second east. Relative velocity center of mass system with respect to 3 kg bodies. I choose the horizontal direction towards east as the positive direction of x-axis. And the horizontal direction towards west will be the negative direction of x-axis. The mass of the first body are denoted by m1, which is equal to 2 kg. The velocity of the first body is 3 meter per second towards east. So in vector form, we can write the velocity of the first body as 3I cap meter per second. Mass second body may be denoted by m2, which is given to be 3 kg. The velocity of second body you can denote it by v2 bar, which is 4 meter per second towards west. That means the negative direction of x-axis. So in vector form v2 bar, you can write minus 4I cap meter per second. The mass of third body may be denoted by m3, which is equal to 5 kg. The velocity of the third mass is can be denoted by v3 bar, which is 5 meter per second towards east. So you can write 5I cap meter per second. So the velocity of the center of mass, the system of the three bodies is given by m1 v1 bar plus m2 v2 bar plus m3 v3 bar by m1 plus m2. Come on, you can copy down and complete the simplification part yourself. You can start writing the solution of the problem. You can start copying the solution of the problem. Simplify it yourself. So you get 1.9 I cap meter per second is the velocity center of mass. You're asked to find relative velocity center of mass system with respect to 3 kg body. That means you have to find relative velocity center of mass with respect to m2. So relative velocity center of mass with respect to m, second body of mass 3 kg equal to vcm bar minus v2 bar. That is 1.9 I cap meter per second minus of minus 4I cap meter per second. You can copy down and complete the simplification part. So you get 5.9 I cap meter per second. That means relative velocity center of mass with respect to second body of mass m2 is 5.9 I cap meter per second. I cap is unit vector along positive x-axis towards east. So answer will be 5.9 meter per second towards east. In case you need more time to copy the solution of this problem, you can take a pause and take your own time. So for question number 25, third option is the answer. Next, I am going to discuss the next question. Question number 26, which was given one of the previous AMCET exam papers also. Two particles of equal mass have velocities v1 bar equal to I bar meter per second and v2 bar equal to 2j cap meter per second. So again I start reading from beginning. See the question number 26. Two particles of equal mass have velocities v1 bar equal to I cap meter per second, v2 bar equal to 2j cap meter per second. First particle has an acceleration a1 bar equal to 3I bar plus 3j bar meter per second square, while the acceleration of other particle is 0. The center of mass of the two particles moves in a. You have to find the nature of the path along with the center of mass moves. Let us find the velocity of center of mass system of the two particles and acceleration center of mass system of the two particles, and find the relation between acceleration of center of mass and velocity center of mass. Velocity system of center of mass system of two particles is given by VCM bar equal to m1 v1 bar plus m2 v2 bar by m1 plus m2. Here both the particles have equal mass. Let m denote the mass of each particle. That means m1 you can take m2 equal to m. So you get v1 bar plus v2 bar by 2. If you simplify it yourself, v1 bar is 2I bar, v2 bar is 2j bar meter per second. So velocity, I mean initial velocity of center of mass. This is. So this is the these are the initial velocity of center of mass system of the two particles. You got I bar plus j bar meter per second. The acceleration center of mass system of the two particles is given by m1 a1 bar plus m2 a2 bar plus m1 plus m2. Here a mass m1 of the first particle is same as the mass m2 second particle. Let m denote the mass of each particle. Acceleration of first particle 3I bar plus 3j bar. Acceleration second particle is 0. So therefore, the acceleration of center of mass of the system of the two particles, you get 3 by 2 into I bar plus j bar meter per second square. You can observe that you have I bar plus j bar here also in both the equations. That means the direction of acceleration of center of mass same as the direction of the initial velocity of center of mass. Direction of the acceleration center of mass is same as the initial velocity of center of mass. So direction of the acceleration center of mass is same as the direction of the initial velocity center of mass. That means the acceleration center of mass, the direction of the initial velocity center of mass. Therefore, velocity center of mass increases in magnitude and moves in a center of mass moves in a straight line path. When acceleration is directly in the direction of the initial velocity, the path will be a straight line path. You can arrive at same conclusion by another way also. If you want to copy the solution, you can take pause and copy the solution. So the final velocity of center of mass can be expressed in terms of the final velocities of the two masses. V1 V bar subscript 1 F represent the final velocity of the first particle of mass. Let us suppose M1, that you can write V1 bar plus A1 bar into T. That V bar subscript 1F is the final velocity of the first particle after time T. V1 bar is the initial velocity of the first particle, that is equal to 2I bar. The acceleration of the first particle is 3I bar plus 3J bar meter per second into T. So final velocity of the second particle, acceleration of the second particle is 0, therefore second particle moves with a constant velocity. So final velocity of the center of mass system of the two particles after time t equal m1 v1 bar m1 into final velocity of first particle plus m2 into final velocity of second particle by m1 plus m2. Here mass of the two particles are equal. So you get final velocity of the first particle plus final velocity of second particle same as the initial velocity of second particle. Because second particle has no acceleration, means it moves here with constant velocity. So 2I bar plus 3I bar plus 3J bar into T by 2. Can also write this way otherwise. 2I bar 2 plus 3T into I bar divided by 2. Plus 3T by 2 J bar. The acceleration center mass system we can find the usual way. That way also can arrive at the same conclusion. But the previous method probably is more convenient compared to this method. So for question number 26, third option is the answer. Next I am going to discuss the next question. Question number 27. Look at the question number 27. Two skaters, one with a mass 65 kg and the other with a mass 42 kg, stand on ice rink holding a pole with a length of 10.7 meter. The mass that is negligible. Starting from the ends of the pole, the skaters pull themselves along the pole until they meet. How far will the 42 kg skater move? Neglect friction. This problem also comes under one of the special cases which I have already discussed. The mass of the first body denoted by m1 equal 65 kg. Mass of second body by m2, that is equal to 42 kg. The initial separation between the two masses are denoted by L, that is 10.7 meter. The two masses move towards each other only due to the mutual internal forces. We consider the two masses and the pole, all the three as one system. So they meet each other at the position of their center of mass. Let S1 be the distance moved by the first mass m1, and S2 be the distance moved by second mass m2 when they meet each other. Let L denote the initial separation between the two masses. As I discussed earlier here, because the two masses meet at the position center of mass S1 by S2, we get M2 by M1. And S1 plus S2 equal to L. You have to find S2 here. So S2 is the distance moved by second mass or 42 kg mass before the immediate. S2 you can write, solve the above two equations, M1L by M1 plus M2. M1 is 65 kg, M2 is 42 kg. That is 65 by 97 or not 7 into 10.7 meter. You get 6.5 meter. If you want to copy the solution, you can take a pause and copy the solution. So for question number 27, you get 6.5 meter as answer. Next, look at the next question. Question number 28. Body falling vertically downwards under gravity breaks into two parts of unequal masses. Center of mass of parts taken together shifts horizontally towards. See the position of center of mass of system at any instant. So this is only governed by the external force acting on system. The internal forces between the particle system play no role in the motion of center of mass of system. Here the body is falling under the influence of gravity. Therefore, the acceleration center of mass is equal to the acceleration due to gravity. Therefore, due to the influence of gravity, the center of mass of the body will be falling vertically downwards, irrespective of whether the body explodes or does not explode. The internal forces between the particles of the body do not play any role in the motion of center of mass. So the path followed by center of mass system is only governed by external force on system. External force system is the same, whether the body breaks up or not. That is the force of gravity. External force system is the force of gravity, which is the same whether the body breaks up or does not break up. So center of mass of the two parts moves vertically downwards with an acceleration equal to acceleration due to gravity, irrespective of whether the body explodes or doesn't explode. That means center of mass moves vertically downwards, does not shift horizontally. So third option is answer. So for question number 28, third option is answer. See the next question, question number 29. A boy of mass 36 kg moves from one end to the other end of a boat of mass 72 kg on still water. The length of the boat is 2.7 meter. The displacement of the boat is. This problem comes under one of special cases which I discussed earlier. The mass M1 of the boy or man we denote by small m, that is 36 kg. The mass M2 of the boat is denoted by capital M, which is equal to 72 kg. The mass of the relative displacement of the boy with respect to the boat is denoted by subscript REL, that is 2.7 meter. As I discussed in one of the special cases, the magnitude of the actual displacement of the boat is equal to small m into SREL by capital M plus small m. Similar problem I have already discussed in the past also by two methods. So 36 kg by 72 plus 36 kg into 2.7 meter. So again, magnitude of the actual displacement of the boat equal to 0.9 meters. This problem comes from one of special cases earlier. I have discussed the same model problem earlier by two methods. One by using this conclusion directly, other method without using this conclusion. So same method you can repeat for this problem also. If you want to copy the solution, you can take a pause. So for question number 29, fourth option is the answer. See the next question. Question number 30. This all is also based on same special case. Boat of mass 80 kg is floating on still water. A dog of mass 20 kg on the boat is at a distance of 10 meters from the shore. The dog moves on the boat by a distance of 3 meters towards the shore. What distance from the shore is the dog in the later case? So here also the mass of the person or the body which moves on the boat we denote by M1, that is small m equal to 20 kg. The mass of the boat denoted by M2 or capital M equal to 80 kg. Magnitude the relative displacement of the boy. Instead of boy you have given, instead of man you are given a dog here. Magnitude the relative displacement of the dog that moves on the boat with respect to boat is 3 meters. So if you can solve the problem by two ways again. One method is by directly using the conclusion I have discussed in one of special cases earlier. Otherwise also you can do from basic equations. Magnitude the actual displacement of the boat as I discussed in one of special cases equal to small m into divided by capital M plus small m into magnitude of the relative displacement. Small m is the mass of the man or here boy. It is given mass of the dog, that is 20 kg. Capital M is the mass of the boat, that is 80 kg. Magnitude of the relative displacement is 3 meters. So magnitude of the actual displacement of the boat will be 0.6 meter. Magnitude of the relative displacement is some of the magnitude of the displacement of the boat. I mean magnitude of actual displacement of the boat and magnitude of the actual displacement of the dog. So this is a relative displacement is 3 meter. Magnitude of the displacement of the boat is 0.6 meter. So magnitude of the actual displacement of the dog in this case will be 3 minus 0.6 meter or 2.4 meter. That means with respect to stationary observer on one of the banks or on the bank or shore, the dog moves by a distance of 2.4 meter towards the shore. Initially the dog is at a distance of 10 meters from the shore. Now the dog moves by a distance of 2.4 meters towards the shore with respect to shore. That means the dog comes nearer to the shore by 2.4 meters. So new distance of dog from the shore becomes 10 minus 2.4 meters. That will be 7.6 meters. That will be the answer. In case you are interested to copy the solution, you can take a pause and copy the solution. Next, I am going to discuss this problem by the alternate method also. We choose some fixed point at the origin. We choose some fixed point at the shore as the origin here. Let C1 be the initial position of center of mass of the dog. Let C2 be the initial position of center of mass of the boat. The initial distance of dog from the shore we denote by x1, that is 10 meters. Let C1 dash denote the new position center of mass of the dog. And C2 dash is the new position center of mass of the boat. The dog begins to move on the boat toward the shore. Then from conservation momentum, we can say that the boat will start moving in the opposite direction. The dog stops on the boat will also stop. So distance between C1 and C1 dash gives you the actual displacement, magnitude of actual displacement of the dog. Distance between C2 and C2 dash gives you the magnitude of the actual displacement of the boat. Let D be the initial distance between C1 and C2. According to the problem, the dog walks 3 meters on the boat toward the shore. That means 3 meters the distance moved with the dog relative to the boat. That means distance between the center of mass of the dog and center of mass of the boat will increase by 3 meters. Initial distance was D meter. D. Now it is D plus 8 meters. Now, no net axial force acts on system. We consider the boat and the dog together as one system. The total weight of system is balanced by the upward force of buoyancy. So, when the net axial force on system is 0, velocity center of mass of system remains constant. Initially, both the dog and the boat are at rest. So, initial loss of the dog is 0, initial loss of the boat is 0. Initial loss center of mass system is 0. And velocity center of mass remains constant. Means center of mass of system will be at rest. Therefore, distance of center of mass of system from the origin remains same in both the cases. So, XCM dash, we write it as equal to XCM. XCM is the initial distance of center of mass from origin, which you can write M1 x1 plus M2 x2 by M1 plus M2. XCM dash is the new distance of center of mass from the origin. You can write M1 x1 dash plus M2 x2 dash by M1 plus M2. Here M1 is the mass of the dog, which is equal to 10 kg, 20 kg. M2 is the mass of the boat, which is equal to 80 kg. So the first mass M1 comes nearer to the origin, second mass M2 moves farther from origin. M1 plus M2 gets cancelled. So M2 into X2 dash minus X2 is equal to M1 into X1 minus X1 dash. X2 dash is the new distance of center of mass of boat from the origin. X2 was the initial distance of center of mass of the boat from origin. So X2 dash minus X2 gives you the distance moved by the boat with respect to origin. X1 is the initial distance of the dog from the origin. X1 dash is the new distance of the dog from the origin. So X1 minus X1 dash gives you the distance moved by the dog with respect to origin towards the shore. With respect to the shore, or S1 is the magnitude of actual displacement of dog. S2 is the magnitude of actual displacement of boat. Here M2 is given to be 80 kg and M1 is given to be 20 kg. So you get S2 equal to S1 by 4. You can observe from the figure S1 plus D plus S2 is equal to D plus 8 meters. So some of the magnitude of the displacement of boat and magnitude of the displacement of the dog will be 8 meters. Equal to 3 meters, not 8 meters, it is 3 meters. You have to make this correction. The distance between the center of mass of the dog and center of mass of the boat will increase by 3 meters here because the displacement of dog relative to the boat is 3 meters here. So instead of 8, you should make it as 3 meters. Now you solve the equations 1 and 2. You can substitute here S2 equal S1 by 4. So you get 2.4 meters. That means Magadi. Actual displacement of the rock with respect to shore is 2.4 meters. Magadi, the actual displacement of the rock with respect to the shore is equal to initial distance of the rock from the shore minus new distance of the rock from shore. So new distance of the rock from the shore is equal to initial distance of the rock from shore minus magnitude of the displacement of the rock toward the shore. That is 10 minus 2.4 meters. That's 7.6 meters is the answer. So in case you want to copy the solution of the alternate method also, you can copy the solution of this alternate method also, in case alternate method is more convincing for you. In case you need more time to copy the solution, you can take a pause and take your time.